All right, so this is special parallelograms. We have 3 goals for today. Goal number 1, I can identify the properties of a rectangle. Goal number 2, I can identify the properties of a rhombus. And goal number 3, I can identify the properties of a square. So go ahead and pre-rate yourself on those 3 goals for today. All right, so today we're going to be learning about rectangles, rhombuses, and squares. And the plural of rhombus is rhombi, but also rhombuses work. So either one, I'll use both. All right, so it says assume the shape below is a perfect rectangle. Write down anything you can think about that is true about a rectangle. Go ahead and pause the video, write down as much as you can about a rectangle. All right, so let's see how you did. Okay, so things that are true about a rectangle. All properties of a parallelogram. So all properties of a parallelogram would be opposite sides are congruent. Opposite sides are parallel. I'm not going to mark that too. Opposite angles are congruent. But what's special about these opposite angles is that they're right angles. So hopefully you added 4 right angles. So not just opposite angles are congruent and same side interior angles are supplementary, but they're all 90 degrees in a rectangle. We also know that something about the diagonals. We know the diagonals bisect each other, but in a parallelogram or in a rectangle, diagonals are congruent. So you probably didn't come up with that one. So let's make a list of rectangular properties. So first thing is all properties of rectangles. Properties of parallelograms. Properties of parallelograms. So every property that we have for a parallelogram is true about a rectangle. Why? Because a rectangle is a parallelogram. But there's 2 extra things. First off, it has 4 right angles. And the other extra thing is that the diagonals are congruent. Diagonals Now remember, in parallelograms, diagonals bisect each other. We didn't say they were congruent. You had 2 sets of congruent pieces. But in a rectangle, you do have congruent diagonals. So you have 1 set of 4 congruent pieces. All right, so here's an example where it says, in the given rectangle, find the value of any variable that you can. Usually I open this up to the class and I say, can someone tell me anything? A, B, C, D, E, F, G, H, I, J, any of those, okay? All right, so let's see what you can find. So what I do know is that this angle right here is 25, and I also know that this is a rectangle. So I know that this is a right angle right here. So 90 minus 25 is 65 degrees. So I'm going to cover this up and put 65 here so I know it's 65. And I'm going to put it right here also. A is 65 degrees. Now I'm going to see any other angles that I know. Okay, well, to help me get through this, there is something very important that you need to know. That is that diagonals are congruent and diagonals bisect each other. So for example, if I knew that this diagonal, now don't write this on yours, but it's just an example here. If I knew this was 10 feet long, okay, what would this be? 10 feet long, right? Now I also, because the diagonals bisect each other, but I also know the diagonals are congruent. So this diagonal is 20. What does it make this diagonal? Also 20. And since this is bisected, this has to be 10 and 10. So if you look, all 4 of those pieces are the same. I don't know what they are, but what I want to do is I want to give them 4 congruent markings. 1, 2, 3, 4. All right, so why is that helpful? Because now if you look, what we have here is we have 4 isosceles triangles. Here's my first isosceles triangle that I'm going to look at. It has 2 congruent sides, but it also has 2 congruent angles. If this angle is 25, so is this angle. So now I'm going to say G is 25 degrees. G is 25 degrees. I can do the same thing and I can do something similar to this triangle right here. It's an isosceles triangle, so I know angle B is 65 degrees. Now I can find angle C because these make a right angle. So this is 25 degrees. This is an isosceles triangle, so this is 25 degrees. This makes a right angle, so this is 65. This is isosceles, so this is 65 also because this is a right angle. So if you look at that, I've only used 2 numbers so far. Let's fill in what I did so quickly. C is 65 degrees, or sorry, 25 degrees. D is 25 degrees. E is 65 degrees. F is 65 degrees. G I already did. Okay, so now I just need H, I, J, K. So now what I'm going to do is I'm going to use the triangle itself. If you look, this triangle is only missing 1 angle. If I'm only missing 1 angle, I can find the other, I can find it using the other 2. 25 plus 25 is 50. 180 minus that is 130. So angle H is 130 degrees. While I'm here, I know vertical angles are congruent, so this is 130. So H and J are 130 degrees. Now I can get I and K a couple different ways. I can use the triangle and add 65 and 65, which is 130, and do 180 minus that. Or I can say this is a linear pair and do 180 minus 130, which is 50 either way. So I and K are 50 degrees. So think about where it starts. It starts by knowing this is a right angle and that these 4 pieces are congruent. All right, let's try another rectangular problem. It says in the given rectangle, so it's telling you in words it's a rectangle, find the value of any variable that you can. So first thing I notice is that the sides are labeled, and I know opposite sides are congruent. So I'm going to say this side is congruent to this side. This is 6c minus 1. This has nothing here, so I cannot set those 2 equal to each other. Let's see if there's a c anywhere else. There isn't, so c is not possible. I'm just going to put NP for not possible. Still no opposite sides are congruent, so this piece is equal to this piece. Both of those are labeled, so I can make an equation. 5b plus 22 is equal to 37. Let's solve this. Subtract 22 from both sides. 5b is equal to 15. Divide by 5, and we get b is 3. All right, so the last one is A, and if you look at this, we know that the diagonals bisect each other, but they're also congruent. This is a rectangle, so all 4 of these pieces are congruent. These 2 pieces are congruent, but they're also congruent to these 2 pieces. So now if you look at first glance, you might say, I can't solve for A because this is blank, but all 4 pieces are congruent, so I can set these 2 equal to each other. 2a minus 13 equals 16. Add 13 to both sides. 2a is equal to 29. Divide by 2. And I get, why did I get 13 for 16? Oh, that's right there. I divide by 2, and I get a is equal to 14.5. And there we go. Okay, so really quickly, in my key, I changed this number to a 25 because it's actually impossible to be 16. Let me explain why it's not possible to be 16. That means that this is 16 also, and that means this whole side's 32. This is the hypotenuse of a right triangle, and that means the hypotenuse is smaller than a lake. So in my key, I changed this to 25. I changed this to a 25. That way the hypotenuse is 50. So let's actually do it with something that's possible. Let's change it to a 50. Your note should be fixed, or I will be fixing it immediately after the screencast. So let's change that to a 25. 2a is equal to 38. Divide by 2. A is 19. And there we go. Now the problem actually, you probably would have never caught that, but I see it and I don't like it. All right, so to recap on rectangles, rectangles have all the properties of parallelograms. Opposite sides are congruent. Opposite angles are congruent. Angles next to each other are supplementary. Diagonals bisect each other. Opposite sides are parallel. But it also, the rectangle has 2 extra properties. It has 4 right angles, and the diagonals are congruent. Therefore, those 4 pieces of diagonals are all congruent. All right, let's talk about a rhombus next. A rhombus is another special type of quadrilateral, but once again, it borrows most of its rules from a parallelogram. The main new thing about a rhombus is that all of its sides are equal, not just opposite sides. So here are our properties of a rhombus. All properties of parallelogram. I'm not going to list them again. It has 4 congruent sides though, so it's not just these 2 sides are congruent, but all 4 of them are congruent. Another new property is that the diagonals are perpendicular. So let's draw in the diagonals. And I need to show that they're perpendicular. Remember, to show that they're perpendicular, I need right angles. So I'm going to put a right angle in there. All 4 are right angles, but I'm just going to draw one. Last one, diagonals bisect the vertex angles. So what that means is that this angle right here is being bisected. So if I knew this was 15 degrees, this is also 15 degrees. But remember, this angle is congruent to this angle. So if the whole thing's 30, this has to be 15 and 15. Same thing goes on here. If this was 30 degrees and 30 degrees, which I'm making up random numbers because obviously that's not making a rhombus, these 2 are also the same as that. All right, so let's try some problems with rhombi in them. In the given rhombus, find the value of any of the variables that you can. So what's really important to do in a rhombus is to know that opposite sides are congruent and the angles are bisected, and that the lines, the diagonals are perpendicular. So I'm going to start by putting in a right angle here. So I know this is 90, this is 90, this is 90, this is 90. I just knocked out 4 of my angles, H, I, J, and K. 90 degrees, 90 degrees, 90 degrees, and 90 degrees. I know alternate interior angles are congruent. So if this is 22, this is 22. But then I have to remember this is a rhombus. In a rhombus, I know that the diagonals are bisected. So this is also 22. This is also 22. So A and E are 22 degrees. So now all I have to get, and I missed one, C is also, is that a C? A, E, D, D, my bad, 22 degrees. All right, so now all I have to get is G, F, B, and C. I'm going to use the triangles for help. So if you look, I know 2 out of the 3 angles. So I'm going to add 90 plus 22, 180 minus that, and I get 68. Diagonals are bisected, diagonals bisect the angles. So that's 68. Alternate interior angles are congruent. So both of these are 68. So this is 68 degrees, 68 degrees, 68 degrees, and 68 degrees. All right, let's try another rhombus problem. CDFG is a rhombus. So if you look what's being labeled on this rhombi, it's the sides. I know that all 4 sides are congruent. So I can set any 2 equal to each other. So I'm going to do 5A is equal to 3A plus 17. And now I need to solve this. I'm going to subtract 3A from both sides. I have 2A equals 17. Divide both sides by 2. And I have A is equal to 8.5. If you look at the directions, it doesn't say find A, it says find CD. CD is this side right here. It's blank, but that doesn't mean you can't find it. It's the same as the other 4. So you can find any of the 4 sides, and that is what CD's length is. So I'm going to do 5 times 8.5, or I could have done 3 times 8.5 plus 17. It'll give me the same answer either way. I get CD is 42.5. All right, here's another rhombus problem. In the given rhombus, find the value of any variables that you can. So first off, I notice the sides are labeled, and I know all 4 sides are congruent. So you look, I can see that C is 5 already, so that's done. Now I'm going to go inside the rhombus and work on my angles. So I know that these 4 angles are right angles. I can put boxes here. but I didn't ask for any of those. I know that this is 32. I know that this is 32. I know that this is 32, but I didn't ask for any of those. I did, however, ask for this angle, so I can find that using the triangle. So I'm going to do this triangle right here. I'm going to do 90 plus 32, 180 minus that, and I get that that is 58 degrees. So A is 58 degrees. All right, now I need B and D. So a rhombus is not a rectangle. A rhombus is a parallelogram, though. So I do know that diagonals bisect each other. So these two pieces are congruent, and these two pieces are congruent. So I know D is 4. Now, if you look at B, you first might be saying to yourself that I can't get B. But that is not true. You can get B. Okay? Now, here's why you can get B. If you look at where B is, it is on, well, B, if you look at this triangle right here, let's look at this. I'll get to my point here. That is, I'm going to draw it over here. This is a right triangle. I know that this leg is unknown. That's my double tick mark side. This is 4. And I know that, I used double or single tick marks twice. So I'll do triple here, triple here. I know that this is 5 right here. This is my single tick mark. So if you look at this, I can figure out the third side using Pythagorean theorem. So I'm going to do x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. Subtract 16. X squared is equal to 9. And then square root, it can be a positive or a negative answer. So plus or minus. X is either going to be positive or negative 3. So if you look, this is a length. It's got to be a positive 3. So I can go through and label this with a positive 3. That means B is 3 also. All right. Next, what we need to do is we need to move on to our final shape, which is a square. A square has many different properties, but if you check the list, you notice that all that it does is borrow from our previous shapes. The simplest way to describe a square is that it's a parallelogram, a rectangle, and a rhombus. So it has all of the properties that we've talked about today. So properties of a rectangle, all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. All right, so let's go ahead and solve this square because it says so right here. So I'm going to start with what I see. I see the number 5 in here, and that's the only number I see, and I see that it's this piece right here. So remember, the diagonals bisect each other, so these two are the same. But then also, the diagonals are congruent, so those 4 pieces are the same. So I know that M is 5. All right, now I go to my angles, and at first I say, like, I don't know any angles, but remember, a square is a rhombus. So I know that all 4 of these angles are 90 degrees. So this is 90, 90, 90, 90. So that's I is 90, J is 90, K is 90, and L is 90. All right, so now that I go to these outside angles right here, since it's a square, I know this is a right angle because it's a rectangle. But I also know that it's a rhombus, so these two angles are the same. So if this is 90 degrees and these two have to be the same, these have to be 45 and 45. So A's 45 and B's 45. That works on all those corners. So D's 45 and C's 45. E and F and G and H. Squares should be the easiest, but you do have to remember the property that the diagonal bisects the angle. It's 90 degrees, so that's 45 and 45. All right. Next problem here. In the given square, find the value of any variable that you can. All right, so I know that this piece is congruent to this piece, which is congruent to this piece, which is congruent to this piece. So I do know this is 5. It wants me to find A. If you look, I know that the 4 sides are congruent, but they're not listed. So some people will want to say that you can't find A. But you can because of the fact that this is a right angle. So once again, let's look at this right triangle right here. We're going to do leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. Okay? All right, so the whole purpose of this is to teach you how to simplify a radical instead of using a decimal. All right, so 5 squared is 25 plus 5 squared is 25 equals a squared. 50 equals a squared. Square root to solve. Now, in chapter 1, we would say, all right, square root of 50, we don't know it. Let's punch it into our calculator. What's the answer? So instead of doing that, this is where I'm going to teach you how to write in simplest radical form. In order to do that, you must know your perfect squares. So 1 squared is 1. We don't write that down because 1 goes into everything. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. And that's what I'm going to ask you to go up to for the rest of the year. Just know up to 225. And if you need a calculator to get one of them because you forgot them, you have one. All right, so here's what you're going to do. You are going to find where 50 falls. So 50 would fall right here. So we don't need any of these to the right. They're out. So now I need to know if 49 goes into 50 as a multiplier. So it's 49 times something, a nice number, 50. It's not, so moving on. What about 36? I can check my calculator by doing 50 divided by 36. I get a decimal, so no. Does 25 go into 50? It does. So I'm going to write 25 right here, and then you're going to say how many times it goes in there. It goes in there twice. Now you're going to simplify. We know this. We know the square root of 25 is 5, and then we don't know the square root of 2, so we leave it in our answer. So we have a is equal to 5 root 2. All right, that's it for today. You can go ahead and re-rate yourself on your goals, your 3 goals